Hey guys, this is another visual mathematical video. This is kVp, and we're going to be talking about the 15% rule. When we talk about kVp, it's our other technical factor that we select on the control panel. kVp has to do with the penetrability of the beam, like how is it going to pass through the patient. It has to do with the wavelength, the frequency, the energy of the beam. So when we talk about the fact that it's relating to the penetrability, that tends to relate to the quality of the beam, but it also affects quantity, because remember that kVp is really the potential difference. It's the degree of attraction between the positive anode and the negative cathode. And when the kVp is higher, the degree of attraction between those is stronger. And when it's stronger, it means that it's more likely to pull more electrons from the cathode over, because the degree of attraction is stronger. So kVp affects not only the quantity of the beam, but it also affects the quality. Now, when we say it affects the penetrability, basically what you're determining is if you end up with a photon like this, or a photon like this, or a photon like this, which would be really, really, really penetrating. And I know my amplitudes aren't equal, but this would be relatively long wavelength. This wavelength is shorter. This one, let me find two that are relatively equal. This one shortest yet. So this one would have the highest energy, the most penetrability, the shortest wavelength, the most increase in frequency. All right, so this one would be less penetrating than this one. Now, when I say it affects the contrast on the image, ideally this is going to give you black on your image. Okay, that'll give you exposure. This one might give you exposure as well, but this is more likely to give you probably a gray, because it's not coming through the patient as much. This one is likely to be absorbed in the patient, so this would give you white on your image, so no exposure. So the difference between the white, the gray, and the black, that is our contrast. Because contrast is the visible difference, what you can see. It's the visible difference between adjacent exposures. It's basically what makes the anatomy stand out. The reason we can see bone is because all that radiation that went towards that bone got absorbed. So there was nothing to expose the image receptor. That's why it's white. We can see the black because that's where all the radiation passed through and struck that IR and gave us the black. But the reason we can see between the two is because there's contrast. There's a visible difference between black and white. Okay? So kVp ultimately affects the contrast on an image. That's why during lecture I said if you only wanted to change the quantity of photons, you should change your mass value. If you wanted to change the quantity of photons and it was okay to change the contrast as well, then you could alter your kVp. All right, I'm going to get rid of this, and I'm going to go back to talking about kVp with regard to mathematics. Okay, now they tell us in the reading that the kVp, that if we were to double the kVp, it would actually affect the exposure by a factor of 4. So that if you, let's just say you used 50 kVp, and these are random numbers, but with 50 kVp, that gave you 500 photons that you created. They tell you if you double your kVp, so double 50 would be if you went to 100 kVp. Now, would we ever do that? No, there's no reason to. But if we were to double our kVp, it would quadruple the quantity. So by a factor of 4, which means we would end up with 2,000 photons. How did I get that? because 500 times 4 is 2,000. 20,000. I'm confusing myself. 500 times 4, 2,000. Okay, that would give me 2,000 photons. So if you were to double your kVp, you would quadruple the quantity, but we don't ever do that. What do? We typically use the 15% rule, okay? And the 15% rule says that if you alter the kVp by 15%, it has the same effect on the IR exposure. IR is image receptor. Same effect on IR exposure as if you were to double or halve your mass, meaning take 1/2. And I showed you that little representation with the 3 tubes and changing that, okay? So if you alter your kVp by 15%, it would have the same effect on the image receptor as if you were to double or halve your mass. So you really have a choice when you're altering your kVp, because remember, it's going to affect your contrast. So with regard to kVp, if you were going to raise it or lower it, let's just use something simple. Let's just use 60 kVp at 2 mass. Okay, let's say you use 60 kVp at 2 mass and it was considered underexposed. And if something is underexposed, it's too light. Not enough exposure on that, so it's too light, underexposed. So you had to go back and fix that. What's one way you could fix it? Well, I told you the one way you could fix it is you could go back and you could double your mass value, leave that alone. So you could use 60 kVp at 4 mass, and that would double your exposure of this original one. That would give you double the exposure of your original technique, okay? All you're doing is changing the quantity only. That would give you twice as much exposure because you've doubled your mass. The other thing you could do would be to utilize the 15% rule. So if you use the 15% rule and you wanted to raise the kVp by 15%, you could literally take 60 times 0.15, which is 15%, and it gives you 9. And then you add that back to your original 60. So 69 kVp is 15%, and you would maintain your mass. So if you use 69 kVp at 2 mass, you would double your exposure because the 15% rule says that it does that, but there would also be a change in contrast, okay? There would be a change in contrast, which right now we're not there to talk about. So you would double your exposure, but recognize 69 kVp photon is more penetrating, correct? So you're going to end up with more exposure, but you're going to alter your contrast as well, because when you raise the kVp, your contrast decreases, but we'll talk about that at a later date. Let's say that you were doing, let's keep the numbers simple, okay? I'm going to get rid of these. Let's say you use 60 kVp at 2 mass and it was overexposed. Now what do you think overexposed means? If it's overexposed, if you go to the beach and you get overexposed, what happens? You get too dark, right? You get burned. So it's too dark. So you have to lighten that a little bit. How can we do that? Well, one thing we could do would be to use half of our mass value. So we could use 60 kVp at 1 mass, and that would give us half of the exposure of the original one. That would be half the exposure of this one. The other thing we could do would be to decrease kVp by 15%. Well, I knew that 60 times 0.15 was 9, so now I subtract that from 60. So I could use 51 kVp at 2 mass. And that would also give me half of the exposure, but at the same time, it would alter my contrast. So you can alter the kVp by 15% and it has the same effect as if you were to double, which was our first example, or half the mass. Okay? Now, I'm going to erase this part as well. I'm going to show you one more thing. Does it make sense if I said to you that with that 15% rule, let's say that you use 60 kVp at 2 mass and it was diagnostic. It was optimal. It was a quality image. Those are all good, meaning it was good all the way around. Well, you wouldn't really want to alter your technique, but you could. Let's say for whatever reason you couldn't get it to 2 mass, the machine would only stay on 1 mass. But you want to make something that would be equal to this. So if I wanted it to be equal, what could I do? Well, if I was stuck and the machine would only give me 1 mass, but I want it to be equal and this is half, then the way I could get back to that would be to raise this, right? What would represent in kVp a doubling? 69 kVp. So I could use 69 kVp because that represents doubling. This represents a half. So if I doubled it and then I took half of it, it would be back to the original technique as far as exposure. What else could you do? You could also say it was set at 4 mass and I couldn't change it. Well, that represents a doubling, correct? So to bring this down by half, I could use 51 kVp at 4 mass, and that represents a halving. Now, both of these would definitely affect the exposure, but it would also alter the contrast. Okay, so if you wanted to double it, then you could either double the mass or raise the kVp. If you wanted to halve your exposure, you could halve your mass or decrease your kVp by 15%. And if you wanted to maintain the exposure, then if the mass doubles or halves, the opposite has to take place. So if the mass went down by 1/2, the kVp would have to go up by 15%. And if the mass doubled, the kVp would have to go down by 15%. Because the 15% change in kVp has the same effect as if you were to double or halve your mass. Okay? It always affects your contrast there, because remember, raising the kVp, if your photon started out like this and you raised it 15%, you're going to get something more like this. Because you're raising the energy, you're shortening the wavelength, and you're increasing the frequency. So kVp and mass have to go together. You can't make an exposure with one and not the other, because they affect different things. They affect some of the same things, but they affect them differently. So this mainly is your penetrability. And with mass, it's mainly your exposure. Okay, hopefully that helps it make a little bit more sense. Again, just to reiterate, the 15% rule says that when you alter your kVp by 15%, it has the same effect on your IR exposure as if you were to double or halve your mass. Same effect. Doesn't mean that's what you're doing. Means that when you alter it by 15%, it's affecting your exposure to the image receptor the same way. All right, I hope that helps clear things up. Thank you so much.